Just be right. So there's three kinds of designs, and we're going to kind of sketch out all three. We only talked about two yesterday. There's one more. Then we're going to do some frappies. Yeah. So this is the completely random. You split up your experimental units, whether they're subjects, plots of land, whatever, randomly assigned. I just put treatment 1 in control, but there could be treatment 1, treatment 2, treatment 3. There could be a bunch. I just put 2. And then you compare the response variables. So that's like the general setup of anything that tells you to do it completely randomized. So I'm using that to try to teach you like the thought process, but not, it doesn't actually count. It's supposed to say control. Are people still writing or not? Okay, skip match pair for a second. Go down to block. We talked about that yesterday. So there's like a free separation. You might want to watch like what it looks like. I'll give you time to write it. You still start with your experimental units. But now you're putting them into block 1 and block 2. And that's not random. Like you're doing that intentionally. Let's put this here too. Age, gender are the most common blocks. And then, like within each block, you do treatment 1, 2, 3, 4, etc. if needed. And the control, and that's random. And then you do the same thing in block 2, so you're doing like 2 basically separate experiments, just running them like at the same time. And then we compare the response there. Oh yeah, yeah. Sorry, that should be treatment 1. Good catch. So just, I think it's helpful to like kind of see both of those at once to realize that block is just like 2 of these. So with completely randomized, you're doing this process. With block, you're doing that process twice or 3 times if there's 3 blocks, whatever. But block just has like this extra layer here. I think that's easier to see in the diagram. And then matched pairs is like very specific blocks. So if we had a list of like, we were talking about integrated math yesterday. Let's say I think it works better in like above average and not as well as below average. Matched pair would be you pair people up that are as similar to each other as possible. You give one of them integrated math and you give one of them not integrated math. So I would list like everyone takes a pretest. I list their scores from high to low. I take the top 2, randomly assign 1 to take integrated math, 1 to not. I go to the next 2. 1 takes integrated math, 1 doesn't. This is random. I go to the next 2. So you're getting those 2, like the 2 top scorers are one's gonna go each way. The next 2 top 1 will go each way. And so you get similar groups because you took the pairs of people and just separated people that were similar. All person most similar to you is you. So like you might do something. We talked about that M&M's thing before. That's really like a matched pairs with yourself. So like you jump. What do we say? Like it makes you jump higher or run faster. Run faster. So you run, then you take the M&Ms. Maybe you wait a while, randomize, whatever. But then you run again. So you're comparing you to yourself. So that's like your own matched pair. It could be a couple other cool ones, but they're in the frat piece, so I don't want to give them away yet. But it would look like this. You take experimental units. You have pair 1, pair 2, pair 3, and there's going to be a bunch of those because you're splitting it into groups of 2. So if you're like 100 people, you're going to have 50 pairs. You're never going to have to diagram this. That would be absurd. And then it would just be in every pair, one person gets the treatment and one person gets the control. So the splitting into pairs is not random. That's very intentional, but into the treatment and control, that is random. That's supposed to say RA right there, like random assignment for all of those. And then we would compare response variables. What? So notice that matched pair and block are really the same thing. It's just when there's matched pairs. Like if I have 100 people and I block it into two things, it'd be like 50-50. If I pair it, it'd be 2-2-2-2. So it's just more groups. So you have like the same idea, it's just more groups. Andrew, are you sitting on your phone? Go to the office. Like I'm pretty chill when I'm like you guys are working, but I'm up here teaching and you're just gonna chill on your phone? Come on. I got Mr. Hamden coming down for phone usage. Alright, thanks. Alright, let's look at that first one on the Friday. I just want to talk like in general about the 3 different kinds. We're not even going to do like the questions they asked. But I want to go through, first of all, like block and then matched pairs, the difference. Pretty similar, but there's a difference. So we got these windows. We're trying to see like there's 2 types of windows we're gonna put. So we're gonna put like window type A and window type B and see which one like keeps the heat in the house. Compare the heat in houses. So what matters is the direction it's facing, right? Like facing east, facing west, with the sun rising northwest. Those are gonna be different things. So for example, if I were to put window A over here and window B over here, and then all of these like perform better, do I know if it's because of the window or the direction it's facing? I wouldn't know. So I don't know like whether it gets better or worse, but I know the ones by the window are going to be different because they can get like the sun shining on them all the time, and these ones don't. So again, if I did like, let's even say I do completely random, and I get these 6 over here are going to get window type A, the ones away from the window, and these 6 over here, window type B, the ones by the window, and then it turns out these are better. I don't know why, right? I don't know if it's because they were over there or if it's because of the window type. Because they're all just staring. I don't know if you know what I'm saying or not. Yeah. Okay. So we have to consider the direction that the window is facing. So if I were to do block, I would block it. Now let's do match pairs first. Which window is most similar to window box 12? Box 1. That's a pair. 12 and 1. That's a pair. So what I'm going to do is like flip a coin, or if I really wanted to put the 2 numbers in a hat, mix it up. That doesn't really make sense. I'd flip a coin, and one of these gets window A, and one of these gets window B. Window or box 2, what's the most similar? 2 and 3, 4 and 5, 6 and 7, 8 and 9, 10 or 11. There is actually another way to do match pairs. Some people like looked at it differently. So I paired it up by like north, west, west, and south, east, east. Some people thought of like 11 and 12 go together. Like those could be similar pairs, right? Because they're both like northwest. So you could have paired up like 12 and 11 because they're northwest. These 2 are like due west. These 2 are like southwest. 2, 2, 2. The important idea is for all of those pairs, I'm going to flip a coin. One of them gets window A, one of them gets window B. And then I can tell whether window A or window B was better because they're all like grouped kind of the same. Block is like the same idea. It's just not pairs. And sometimes it ends up being pairs. But if I were going to block this, I would do like 8 through 11 in one block. Flip a coin, put them in a hat, mix them up, whatever. 2 of them are going to get window type A, and 2 of them are going to get window type B. And because they're all facing kind of the same direction, if A is better, I know that's why it was better. Because that's the only difference, because they're all facing the same direction. And then like 12 and 1 could be a block. 2, 3, 4, 5. And 6 and 7. So they are the same idea. It's just pairs are just groups of 2 and blocks are bigger. And then completely randomized. We just put in a hat and mix them up. I'm just going to put hat, comma, mix. I could get anything. So that's not the design I would use if I were doing this. Like I said, you could get all of window type A on the east, and then they all face the window, so I don't really know. Was it because the window type of the direction it was facing? So I'm not gonna like answer their question. But other questions on anything I'm talking about? Okay. Give me like thumbs up, down, sideways. How we feeling about this? Like, do you understand what I'm trying to get at? Okay. All right, let's look at. 2004, problem 2. So go ahead and try it. For part A, you put one and two together. Part C is the real question. That's what I think is the hard part. Picture you can. What was the other book here? Because you gave me. Yeah, that's more interesting. The other one is too. Really? I've never read that. Bunnies? It's about bunnies. Really? Like, what's the? Okay. I don't know that one either. Okay. Nature's yeah. Nature's crazy. Nature's wild. Literally. Okay. So for part A, they say age matters, but gender doesn't. So you basically just ignore the gender column and you're picking the two that are closest by age. So I don't think that's too difficult. But that's what I got. If you want to compare. Good. And then part B says like now age and gender matter. So I took like the 20-year-old, 1-year-old male and found the male that was closest in age, so like 23-year-old male. So I put those two together. And then female 20, I found female closest in age, so I put those two together. Again, I don't think that's like earth shattering or anything, but that's what I got. If you want to compare. The part C is what I like really wanted to talk about. Questions on A or B though before I. Okay. So part C says. So I got my blocks. Let's say I'm doing this one. They're saying we're going to randomly choose 3 of the blocks to get the new formula, and 3 of the blocks to get the old formula. So, for example, and it's random, so this is my randomness. Let's say that I gave these 3 the new formula, and then I gave these 3 the old formula. Well, remember, these are similar to each other. So this is not what we want to do. I'm having trouble explaining why it's not what we want to do. But let me explain what we do want to do. What we would want to do is we put these 2 in a block together because they're similar. I want to give one of them the new treatment and one of them the old treatment. We put these 2 in a block together because they're similar. So I want to give one of them the new treatment and one of them the old treatment. Let's say I did it randomly and I got like that block, and there's no other young people, but say that block. And then they all get the new treatment. And it works better. But is it possible it just worked better because they were younger? Right? So I don't know if I do it that way, I don't know like what's causing what. So what I want to do, I split them into pairs for a reason. So this is like you get treatment 1, treatment 2. There's a pair, you get treatment 1, treatment 2. There's a pair, you get treatment 1, treatment 2. So you wouldn't want to do what they say. But I would say I flip a coin for each pair and give one of each pair the new and one of each pair the old. Questions on part C. That's kind of the main deal. Let's go to 2001, problem 4. This is pretty tough usually the first time people see this. Think about it carefully. said A was better. Raise your hand if you said B was better. Crap. A is better. So let's talk about it because I was not responsible. This is hard. Like this is every year. Most people miss this right away. And I have to explain it, and then like some of you will understand it, but I'm not sure. Oh, okay. So this is not saying like variety 1 will go in these 4 spots and variety 2 will go in these 4 spots. If that's what it was saying, that would be a different answer. But it's saying which one would I block by. So think about blocking. We'll do like one experiment on males, one experiment on females. We'll do one experiment on old people, one experiment on young people. We'll do one experiment on above average in math, one experiment on below average in math. So this is because the variable that matters. Like what's the issue? What's the underlying issue that matters where we are? It's the trees, right? So think about splitting male female. I want to do one block that's close to the woods and one block that's not close to the woods. So you're going to split it into these groups because that variable matters. So you do subsets based on what matters. And then within each subset, it might be like variety 1, like I'll randomly assign. So I'll have 2 of variety 1 in here, and maybe they're there, and 2 of variety 2. So now if So now, if variety 1 grows better, I know it's because it's variety 1. It's not because it was like closer to the woods. So everything in that experiment is going to be. It's like it's one experiment there because those are close to the woods. That's totally different than ones that are far away. So I want to do one experiment there and another experiment there. If we were to do blocking scheme B, I still have to randomize, right? I still have to randomly put the 2 variety of trees into those 4 squares. Let's say that I randomized it and I got 1, 1, 2, 2. And then I find out like 1 grows a lot better. Do I know why? I don't know if it's because tree 1 is legitimately better or if it's because those were just closer to the woods. So what I want is close to woods, you get variety 1, variety 2. Far from woods, some get variety 1, some get variety 2. And then I can tell, like maybe both of these are better, and now I know variety 1 is better, and it was better close to the woods, it was better far from the woods. It could be that, variety 1 is better if you're close to the woods, and variety 2 is better if you're far from the woods. But the idea is you're splitting based on the subset that matters, like male, female, old, young, close to woods, far from woods. You have to split up based on that big variable. Does that help? How many people can see how A is maybe-ish convinced you a little bit? Okay, so which is the block? So A is better. Here's the simplest way. Since the blocks, big words, I don't know if it's simple, because then the blocks are homogeneous regarding distance from the forest. Like when we split by gender, our blocks are homogeneous with respect to gender, right? All these are males, all these are females. If I split by age, my blocks are homogeneous with respect to age. All the old people are over here, all the young people are over here. So you want your blocks to be all the same as each other, homogeneous. Does that help? Like that makes sense. Okay. And then why do we randomize? So it's basically asking why do we randomize in general, but it does say in the context of this experiment. So you're going to use this experiment to discuss why we randomize in general. So we hope that randomizing So you can say like mixes up, you can say levels out. So there's other variables that might influence how fast the tree grows, right? Like maybe the soil is different, maybe there's animals buried in this one. And by randomizing, we're just hoping that the best we can, those get evened out into two groups. So we hope that randomizing mixes up, levels out other variables. I haven't talked about context yet, so I'm going to say that impacts tree growth. So that's the idea. We hope that randomizing just like evenly distributes things, and then I'm just putting the context of this problem. Questions on that? Yeah, please.
So, in some instances in the problem, we sort of have to guess what the subsets are in the blocks. Because, like, they didn't tell us that they were going to plant close to far, right? Like, they just said that there were 2 blocks. Like, are we just supposed to, like...
You're not supposed to guess. What they're hoping for here is that you would make the leap that, like, oh, those trees probably match.
Okay.
Does that answer your question?
Yeah, that makes sense.
So you understand, like, the A versus B, you're just like, how am I supposed to know?
Yeah.
So if there were trees, like, if there was a river up here, these trees aren't there. Let's do this. These trees are not there. In either case, there's a river up there. Now which blocking scheme is better? Now it's B. Because these ones are homogeneous in the idea that they're like the closest to the river, and these are the farthest from the river. Does that make some sense? You want to start your question over, or you want me to just talk? You're saying like if the river was there. Okay, so if the river's here, what I want is my blocks to be homogeneous regarding how far they are from the river. So I want, it's not ideal because like these aren't quite exactly the same distance, but these are closer, these are farther. So I would want to randomize like type 1 and type 2 within here, and then if type 1 is better, I can assume it's because type 1 is better, not because it was close to the wall. That helps. Okay. And then the far, same thing with the far. Like if one's better or worse, I know it's because of that tree variety, not because it was further from the water and getting less water. Alright, there's another one that's very similar, so let's jump to that. The very back one. 1997, problem 2. Try that. That's another window problem. So like, oh, and you're not, again, like you're not supposed to guess, you're supposed to kind of infer,
Yeah.
like, what matters. And that's what I think it tells you. You got a new and old type of food. That's the main. I don't know about you guys, but when I read through this, it starts to, my eyes glaze over. So it's colder up here, warmer down here. Oh, there's a heater. I guess that's why. That'll help you. Remember, you want your blocks to be homogeneous with respect to whatever matters. Separated by male, female, closest to river, further from river. So think about it that way. Yeah. What does that mean, homogeneous? All the same. Like homo, just same. So like they're all far from the river, or they're all close to the river, or they're all males, or they're all females. Thank you for asking that. you're done, 3 of these are acceptable ways to split it up. So you can tell me which one's not. Like, not allowed. Remember, everything in the group has to be the same with respect to whatever it is we're dealing with. Anybody else remember the part where I said that? I'm not giving it away yet. I don't know if he's right or not. So for A, I said 1 through 4, and then I said 5 through 8. Are these all the same as each other? As far as like distance from the window? Or distance from the heater, yeah. Are these all the same as each other? Yes. So this is a very valid one. This is the one I did. I just said for these top 4, I'm going to randomly split it. For the bottom 4, I'm going to randomly split it. And then, if it's like type 1, type 2, type 1, type 2, I don't know, I just randomly did that. But if type 1 is better, I'm not sitting there asking myself, well, is it really better, or is it because it was further away from the heater? Because all of these are the same distance away from the heater. So 1 is okay. So that's good. 2 says 1, 2, 5, 6. And then 3, 4, 7, 8. Is this group the same as each other as far as distance from the heater? It's not. Same with this one, right? So this is a bad option. This is like option B from the last problem. So just judging by your responses, I think we've gained some understanding. So this is bad. 1, 4. So if I did like these 2, and then like these 2, these 2, these 2, is every pair similar to each other with respect to how far it is from the heater? This is like the top corners, right? Those 2, bottom corners. So yes, that one's good. And then 1, 2, I don't think this one's quite as good. So now I said like 1 and 2 go together, 3 and 4 go together, 5 and 6, 7 and 8. That's not quite as good because like 2 is closer to the heater than 1, unless the heater goes all the way across, which I'm not quite sure about. But this isn't bad either. I think A and C are your best, D is okay, and B is bad. Give me thumbs up, down, like how much you understood what I just. Alright, good. Okay. So what I wrote. Backspace. Good thing Elliot's not here to yell at me for doing it. Okay. So I like my distance from the heater. So I'm telling them like this is the variable that I think matters. This is how I'm going to separate things. 4 north and 4 south. Within each block, I'll put 4 of the numbers in a hat, mix it up and pull out half. Question on that. Alright, I don't think we have time for a whole one, but we can get something else done here. Actually, let's look at 2002 problem 2. So we're just gonna talk through it. I'm not gonna like write down the answer from their question, but I want to discuss it. We've got 100 volunteers. We got 6 months to work with. We're in Seattle. We got 6 months to work with. And we've got new waterproofing and old waterproofing. So Seattle's matter because of the boots. We're dealing with boots. Like, so it's really rainy, right? Although it doesn't matter because everybody's in the same spot. So but there's a couple ways to do this, and there's a really cool way that I'm trying to get you guys to think of. I'm not going to tell you yet. One way to do this that is not wrong would be to completely randomize it. Say, put the 100 volunteers' names in a hat, mix them up. The first 50 I pull out, you get the new pair of boots. The next 50, you get the old pair of boots. You guys all go wear them for 6 months. You bring them back. I'll measure whatever I'm going to measure at the end and see which one was better. Does that make sense for completely randomized? Totally valid way to do it. But there is a better way. And you would have gotten credit for what I just said. But I'm trying to push you to see the better way. So, in that situation, is it possible that when I randomize, all the people with new boots have like office jobs, so they don't do anything all day, and all the people with the old boots are like construction workers, so they're outside getting the crap beat out of their shoes all day? Is that possible? Yeah. So then these boots like don't do as well, but I don't know if it's because of the rain, like because of the new or old design, or it's because they were like outside all day in the elements. How do you fix that? Okay, so Evan just said she said we're gonna go inside jobs. This is not quite what I want, but I like this. I want to talk about it. And then some will get the new, some will get the old, and we'll randomly do that, right? What did she just do? What kind of design is that? You don't know? You know what it is? It's block. That's block. So that's like blocking on, I think that whether you work inside or outside matters. So we'll do 2 separate experiments, one for inside and one for outside. Great way to do it. 100% credit. Not the cool thing that I was looking for. There is a really cool way to make sure that there's, even here, there could be questions like the inside workers, some of them might be super active after work, and some of them might go home and sit on their couch. So, but there is a way to control everything. Yes. Okay, let's go with that. So, not quite. It's good. It's good. You guys are giving good answers. I'm not trying to like critique. But let's go. Let's say that the new people wear them in like the new treatment wears it in the middle of the summer, and it just happens to be like not a rainy season. And then the next 3 months, everyone wears the old ones. But now it's like winter and there's slush and mud. So you'd split who wore which ones first. Is that what you're saying? So half the people would wear the new ones for 3 months first, and then the old ones. The other half would wear the old ones and then the new ones. That's. I hate this because it's not wrong. That's a very good answer. It's not the cool thing I'm looking for. What? You like when people just spoon feed you things? That's what you're saying. No. Explain more?
She's asking you to explain
I don't
more.
know. Basically,
Yeah.
you split them into inside and outside, and then do matched pairs.
So inside, outside, based on like match pairs, like based on activity level or something? Very good. Not what I'm going for. There's one way to make sure that it's perfect. Change boots every single day is getting closer. It would say old and smart. It would say old and smart. I'm getting closer. Yes. If you wear a new one on one foot and an old one on the other foot, are they going to go through the same conditions? Yes.
Maybe they walk so
Now, hold on. Yeah.
half of one sidewalk is really bad.
We still need to randomize,
Like
right?
one's closer to the other. One half of the sidewalk is
Some will wear the new one on the left, some wear the new one on the right, because people are right-footed, maybe they walk differently, but that's the cool way to. So I'll tell you, I was sitting in a room, like this is at a conference, I first saw this, with like 25 other new AP Stat teachers at the time, and nobody got it. Like, we were out there, we did this for like 15 minutes, and he was like, you guys just do what I was going to tell you. But that was good.
You started talking about like wearing like a different pair of pants.
Yeah, we
What if
started to
you
get
did it
like
at the
closer.
same time?
Yeah. I just think that's a really cool way to do it.
They get embarrassing.
What if like right top of their foot is roaming the street, so they just like
They're embarrassed, so they decide to hop on one foot.
Yeah, what if one
It's weird to say.
Yeah, each brain makes different size.
Just so you can ruin the experiment.
Yeah.
I'm hopping on one